Alright, here we are at lesson 8.3 and we're going to be learning about laws of logarithms. And you know what, just before we launch right into the first one here, I can make up an example and maybe convince you that these things are true instead of just taking it on faith here. Let's say if we had something like log base 2 of 8, and then we're going to add that with log base 2 of 16, and we're going to find out what that is, and specifically the log base 2 of what should we put in the parentheses here. So just as a review then, how do I figure out, how do I evaluate log base 2 of 8? I can take this by itself here and say that log base 2 of 8 is equal to some number, and now I say that this 2 is the base and y is the exponent, is going to be equal to 8, so y is going to be equal to 3. So in the line below here I can say that this is equal to 3, right? Plus log base 2 of 16, so this wasn't too hard to see. 2 to the power of 3 is 8, so 2 to the power of 4 is equal to 16, right? So I'm going to need some value here which is equal to 7. So you'll see 3 plus 4 is equal to 7, so what will I put into there? So see if I can remember how to erase quickly here. Okay, so here I can say the log base 2 of some argument is equal to 7, so that means 2 to the power of 7 is going to be equal to x. So what is 2 multiplied by itself 7 times? 2, 4, 8, 16, 32, 64, 1, 2, 3, 4, 5, 6 times 2, so it would be 128. So this value is going to be equal to 128. Okay, so is this fairly convincing? Well, 128 just happens to be equal to 8 times 16 when we multiply these two together. So it has to do with the fact that 2 to the power of 3 multiplied by 2 to the power of 4 is going to be equal to 2 to the power of 7. When we're multiplying powers that have the same bases, then we add the exponents. Okay, so that's where this comes from. When think of this log here, this is an exponent, right? So if we're adding two exponents together, that's the same thing as multiplying together the values, the powers, not the exponents themselves, but the powers. Okay, so how can we do this question here? How can we try the first one out? I'll erase some of my mess here again. Maybe I can do this way. Is it working? Not really, hey? How come I can't delete that? Alright, try something like that. Okay, so for the first one here, if I said that 6 is the m times n part, so can we find two numbers that multiply out to 6? Sure, I could break this up and say that's the same thing as log base 2 of 3 plus log base 2 of 2. Okay, so here's an example of that. What could we do here? The log of, if we're going to be dividing, we can subtract the logs. So this would be the same thing as, and now this is an x, so I'll say log base x of 8 minus log base x of 3. It's the same idea. So remember that adding, when we have a number with the same base, 2 to the power of 3 multiplied by 2 to the power of 2 is going to be equal to 2 to the power of 5. So here we're adding, and in this case, when we need to divide the argument, we subtract the logs. So here's an example where you have m to the power of x, right? And remember how we do this. If we had 4 squared to the power of 3, we end up doing 4 to the power of 2 times 3, right? We end up multiplying those. So it's the same idea. Now if the argument is something raised to a power here, we're going to multiply x times the log of that. So for this question here, log base 3 of the square root of 6, if we can think of this, I'm going to rewrite this first of all as 6 to the power of 1/2. Now it's similar to this here. So I can say that is equal to, this is 6 to the power of 1/2, so I'm going to say it's 1/2 multiplied by the log. Okay, here we have log base a, and you'll notice in this expression we don't have any numbers put in here. Now, so the default for your calculator and also the default for logs when we don't write anything in is a 10. So when nothing is written here, then we assume that it is a 10. So if we want to use log base anything but 10 and you want to do it on your calculator, you're going to be using this one. So this is a good one to use for your calculator. So let's say if you had a question and they said, find what's the answer for log base 2 of 7? And the problem is we don't do log base 2 on your calculator, you only do log base 10. So you can say, and we're going to put this in the fraction, and it's kind of easy to remember that it's this log over log. Okay, and now both of them are going to be base 10. Now how do you remember where to put what? The 2 is lower, the base is lower here than the argument, so the 2 goes in the bottom part of this fraction and the 7 goes in the top part of the fraction. And then you can plug this number in and you can actually find out, evaluate it on your calculator. This is explaining the same thing here. It says the log button on a calculator is a base 10, but this button can only be used to find solutions to questions with base 10. So in this example here, you can actually use your calculator to find it out. Okay, let's look at the first example here. We're going to simplify this expression, and when we simplify on these questions, we only want to have one log. So at the end of the day here, we want to only write the word log once and have something really big on the inside. Okay, so looking at this, we've got a few things going on. Okay, so first of all, I've got 2 times the log of x. Now that makes me think of what happened here, right? This would be the 2 times the log of some number. So if I want to put this inside of the log, that 2, in this case it's an x because it's the generic form, is going to be the power. So in other words, going back over here, I'm going to rewrite this first one and write it as log of x squared. Okay, so I've done the opposite of that. Minus, now let's look inside of here, I've got log of y. I can't simplify that anymore yet. Minus, let me get a little bit of space here. I can do the same thing with this 1/3. Again, this 1/3 is multiplying, so it's going to be log of z to the power of 1/3. Okay, I can write it as z to the power of 1/3, or I could do it as the square root, the cube root. So I could also write it as a cube root like that. It's a little bit squishy, but either way. Okay, and now write parentheses. Okay, so now I've taken care of this part here, and I've taken care of this part here, and I've put those values inside of the log. So this is not 2 times the log of x, now it's the log of x squared. Now how do I get rid of the subtraction? I've got 3 different logs and I want to put them under one log. At the end I want it to have just one. So if I remember that subtracting separate logs, it's kind of like I'm going to go from this part to this. Okay, so if I've got 2 logs that are subtracting, I can put them as one log, and the m minus the log a of n, it's m divided by n. So looking inside the parentheses, this inside this parentheses here, I can rewrite that as log of y. Well, I guess I need some more space here. Y, now instead of minus, I'll put it inside this log, divided by this cube root of z. So this is inside that log function right now. So I've combined that together. Now I've got log of x squared minus that. Okay, so again I'm subtracting, right? So now I can combine this as a single log. It's going to be this all over that. So I can write this as 1 log, and then the numerator is x squared divided by this log here, which is y over the cube root of z. Now that's kind of an ugly complex fraction there, so I can just use the same rules that I've used so many times. I can say instead of dividing by this, I can multiply by the reciprocal. So I can write this as log of x squared multiplied by the cube root of z all over y. Okay, see how I multiplied this by the reciprocal. So there I get my answer. Just looking back at this whole complex fraction business, I could also let's look at this and say instead of finding the things inside the brackets first, here I'll just write it over here. I could have also gone log of x squared, and if I take away the brackets, I'm going to get minus the log of y. Let me erase this, plus the log of the cube root of z. So it's still the same rules of mathematics. So if I get rid of the brackets, this becomes a plus. And now it's actually a little bit simpler. I can think of whenever this expression's positive, it's going to be in the numerator. And whenever the expression's negative, it's going to be in the denominator. Okay? And also you could, if you wanted to, instead of writing that cube root of z, depending on what you like, you could also write it as z, oops, this is not x, z to the 1/3. It's kind of neater, isn't it? So, two different ways of coming up with our answer. So whether or not you like to write it this way or that way. Seems to me, in this case, taking away those parentheses first and writing it this way is probably a little bit easier. Okay, so now that was simplify. So simplify means to put it all as 1 log. Now expand is the opposite of simplify. We want to write this out. We want to go to this type of expression where we're writing log many, many times. So here we can write the log base A. Now if it's in the numerator, it's going to be positive of capital A. It's multiplying inside of the log, so when I expand it, that's going to be changed to adding. The log base A of the square root of C. So I'll do this one part at a time. So this is going to be the square root of C. Now in the denominator, we're subtracting the log base A of uppercase B squared. And now this is also in the denominator, so I'm also subtracting the log base A of D. Now you might say that we're done here in our expansion, but there's 2 pieces that we can still work on. It's these ones here. Remembering that the square root of C, another way of writing that would be to say C to the power of 1/2. Okay, so now if I'm going to rewrite that, I could write log base A of capital A plus, now so remember how this works, C to the power of 1/2, it's the same thing as multiplying the log by 1/2 and then only having C as the argument. Okay, minus, and I think you'll see this is very similar, instead of B squared it's going to be 2 times the log base A of uppercase B, and then the last expression here is the same. So there is my answer. Wow, we really expanded that, right? So we have 1, 2, 3, 4 terms for each of those variables that were inside that log expression. Okay, here it says simplify and evaluate using the laws of logarithms. Okay, so we're going to look at this. I'll say, okay, if I want to put this under, the simplify part means to put it under 1 log expression. Log base 6. Now remember, this 8 is positive and this 9, this term is also positive, so we're going to be multiplying them together. So 8 times 9. We're subtracting here, so this will be in the denominator. Okay, 8 times 9 is 72. 72 divided by 2 is 36. So in my next line I'll write log base 6 of 36. So we've done the simplify part, and now we need to evaluate. So evaluate is find out what it is, find what the value is. So I'm going to say this is equal to y, so that now I can change this from a logarithmic to an exponential form. So the base is 6 to the power of y is equal to 36. So y is equal to 2. There is our answer. Let's try this one over here. A little bit more complicated. So you remember the first part, to simplify, eventually we wanted to have it under one log expression. Looking at my first term here, this is being multiplied by 2, so I'm going to put that 2 inside the log expression, so it's going to be a log base 2 of 12 squared. You know what, just from our experience from before with the parentheses, maybe I'll just drop the parentheses, so I'll write this out, log base 2 of 6 minus 1/3 log base 2 of 27. And so this will be, if I want to put this all under one expression, I'll have log base 2, get a little finer point here, of this is 12 squared divided by 6, and also in the denominator will be 1/3 of, oh, you know what, I could have simplified this a little bit because I have this 1/3 here, so I'm going to go and take this, get rid of this 1/3 part and change this to cube root, right? Just like this 2 turned into 12 to the power of 2, this 1/3 is going to be 27 to the power of 1/3, so I can either write it as 27 to the power of 1/3, or I can write it as the cube root of 27. Okay, so then I write multiplied by, oh, that's down here, multiplied by the cube root of 27. Okay, so we've done the simplify part. I guess we can simplify this a bit better. We can say log base 2 of, my numerator will be 144, my denominator will be 6. What is the cube root of 27? I believe it's 3 times 3. So 144 divided by 18, I think that is 8. So I get the log base 2 of 8. Now my very last step will be say, okay, so what's that going to be? I'll say that's equal to y. So 2 to the power of y is equal to 8. Y is equal to 3. Okay. Let's see, I think, do we have one more page to do here? Yeah. So the next one is example 4. Oh, I gotta make things a bit smaller here. If now we're going to be given 3 logs. So here's our first one, our second one, and our third one. So they actually tell us what the values are. We don't know what the base is. That's interesting. It says now evaluate the following expressions. Log base a of 150. So what I want to do is I want to say, okay, I'm going to use my law of logs to figure out, to turn this into some form of these ones that I know already. So really I'm thinking, okay, 150. How can I multiply together some number of 2s, 3s, and 5s to make 150? Well, let's break down 2, 3, and 5, and these all happen to be prime numbers, right? So if I kind of prime factorize 150, 150 is the same thing as what, 10 times 15. 10 is equal to 2 times 5 times 3 times 5. So if I write it out, it's 2 times 3 times 5 squared. 2 times 3 times 5 squared. So over here I can say this is going to be equal to the log a of 2 times 3 times 5 squared, which is equal to the log base a of 2 plus the log base a of 3 plus, now do you see what's going to happen because this is squared? I can make it 2 times the log base a of 5. Okay, now I know what the log of 2 is. It's base a of 2 is, it's 0.3 plus 0.48 plus 2 times 0.7. Okay, so adding these together, let's see, 0.3, 0.48, and then 1.4. I guess I get 2.18. Okay, so my final answer is 2.18. Alright, we're getting close to the end here. Log base a, and this whole thing is being square rooted. So I think the first thing, if I look at this and think this, then it's a little bit easier to say, oh yeah, now I can just multiply the log by a half. 10 over 3. Okay, now the 10 is the same thing as a 5 times a 2. So I'll say 1/2 times the log of 5 times 2 divided by 3. So now breaking this up into 3 logs, 1/2 log base a of 5 plus log base a of 2 minus log base a of 3. Okay, and since this 1/2 is multiplying by this whole log, right? Since it's multiplying by this whole log, that's why I need these brackets here. Okay, so let's figure it out. Log base a of, what were my numbers here? 0.7, 0.48, and 0.3. 0.3 minus 0.48, which is equal to 1/2 of 0.52. Well, if I got that wrong, you guys let me know. So it's equal to 0.26. Okay. One last one. This is a little bit different here. Now we're going to have to figure out what the value of a is. I'm not sure if this actually, we use our new law of logarithms. I think we could have done this on a previous lesson already. If I put this into exponential form, so my base is a, so a to the power of 0.48 is equal to 3. Okay, now it's not that hard. It looks a little bit crazy. What do I need to do to both sides so I get just a by itself? A by itself looks like a to the power of 1. What do I do to a 0.48 to turn it into a 1? And really the question is, what do I multiply it by? Because what I'm going to do is I'm going to say a to the power of 0.48, and then I'm going to do this expression to the power of 1 over 0.48 is going to be equal to 3 to the power of 1 over 0.48. So a power to a power, we multiply those out. 0.48 multiplied by its reciprocal is 1, so I'm just going to get a on the left hand side, which is equal to 3 to the power of 1 over 0.48. So how would you do that on your calculator? You would do 3, and then depending on your calculator, on my calculator there's a button that looks like that. Your calculator might look like x to the y button, right? All those types of things. And then you could go left parentheses 1 divided by 0.48. Another way you could do it is you could do 0.48 reciprocal button and then equals, the equals button. So this is probably works on, it's very, very common. We're either do that circumflex, that hat people call it, or do the x to the y button. So 3 to the power of, make sure you do these parentheses, 1 divided by 0.48 equals, and I believe you should get an answer of, this might be rounded though, 9.86. Okay, and so there is your homework, and I'll see you guys in class.